For over a century, the standard approach in physics has been to observe the universe, write equations to describe it, and then adjust numerical constants until the math is forced to match the data. This process of empirical tuning makes the mathematics a servant to human observation. It assumes our measurements are the primary reality, and the math is just a flexible tool we can bend until it fits. The Marithmetics program completely reverses this approach. It treats numbers not as flexible symbols, but as rigid structural sets. When numbers are viewed as sets, they possess immutable geometric rules. These are boundaries that cannot be adjusted or tweaked by a physicist to save a failing model. This leads to a specific hypothesis. If we follow the strict structural requirements of these sets, the laws of physics will build themselves. If the laws emerge deterministically from the numbers themselves, we no longer need to rely on human observation to define the fundamental mechanics of the universe. In 2023, researchers mapped digital root power tables, or DRPTs. These grids record repeating patterns numbers form when raised to specific powers. They are a natural discovery, the unalterable geometric trace of exponentiation within finite systems. These patterns determine the scaling and interaction of quantities at the arithmetic level. They provide a specific structure for how residues and powers behave. To move from these finite patterns to physical meaning, scientists need a framework that processes the data without introducing human bias or rounding errors. Identifying this underlying structure requires a logic framework that is as rigid as the numbers themselves. That framework is deterministic operator calculus, or DOC. It is a strict system of rules designed to process the patterns in the power tables without corrupting their fundamental geometry. DOC is strictly ZFC conservative. ZFC is the standard set of axioms, the Zermelo-Fraenkel axioms plus the axiom of choice, forming modern mathematics foundation. It never invents new logic. It uses existing set theory, ensuring every step is sound. DOC enforces a rule of admissibility. It acts as a filter that only permits mathematical operators, the functions that process data, that preserve the finite geometry of the sets. Traditional physics often uses illegal operators, like sharp numerical cutoffs, to simplify complex equations. In the DOC framework, these shortcuts are rejected because they violate the structure of the substrate. By adhering to these strict logical constraints, any physical law that emerges is a result of pure mathematical proof. To test this architecture, the program runs a computational execution called Demo 58. The input for this test is a trio of integers discovered through residue filters, 137, 107, and 103. These integers are routed into a discrete Poisson solver. A Poisson solver is a method for determining how a potential field, like gravity, fills a space. This specific solver uses only Fourier operators, filters that ensure the data remains stable across the grid. This calculation allows for zero empirical tuning. The test is to see if the equation will spontaneously generate the mechanics of gravity using only these integers. Demo 58 is the point where the math must either produce chaotic noise or the known structure of spacetime. The Demo 58 execution results in the deterministic emergence of weak field general relativity. The first panel matches the Newtonian slope of inverse square gravity. The calculation also provides exact values for light bending and the Shapiro time delay, the slowing of light near a massive object. The fourth panel records gravitational redshift, tracking frequency shifts through the field. As a negative control, the test is repeated using illegal sharp cutoff operators common in traditional models. When the strict rules of admissibility are ignored, the geometric structure of the calculation fractures and collapses into noise. These results suggest that general relativity is a necessary consequence of the universe's finite mathematical substrate.